Okay, so we've talked verbally about how to use some of the different statements and things that we've been learning along the way, the different variables inside of functions, but just verbally talked about it. Now we're actually going to get into declaring your own function and kind of how that's set up and what the options are. So this is where the heavy lifting for the UnrealScript begins to take place. So what we're going to do right now is go ahead and start out by just declaring or showing the declaration of a function. These are going to show the actual keywords and not the the words you necessarily would be using, but we'll get to an example of that too. So we'll go ahead and do our little heading here. So a function has an optional keyword. So I'm just going to type that out here. So this can be a keyword, and then you have the actual word function. You see the IntelliSense finds that. This is not required here, and you can't just start out by calling or just declaring a function. We'll get to a couple of the more commonly used keywords here at the end of kind of the overview of functions. But for now, I'm just going to throw out the whole declaration of how you can define a function here. So the next thing is going to be the return value. This can be any custom variable type, like a class that you've defined once we get into more classes, or it could just be a variable like a bool or an int. And so what you're kind of defining is what this function is going to be operating on. Not only operating on, but what the main point of the function is and what value you're expecting to get out in return. So for a simple function, this is just going to be one of the base kind of variable types like a bool, int, float, but it can be your own custom structure or custom class. Go ahead and put that in there. And then the next part of is the actual name of the function, which you can, name whatever you want, but we're just going to say name. And then you have an open and closed parens. And inside of these parentheses is where you're going to have any optional values that can be passed into the function. You don't have to pass anything in. You can declare a function with no optional variables or arguments, as they're called in C++. And what that means is that the function is going to do something, presumably on some member variables of a class, and it's going to make some modifications or do some tests, but not have to return any value. Like what the function is doing is going to be self-contained, so to speak, and you're not really needing the result of that to do anything with following that function call. An example of this would also be if the variable type that you were returning was a bool, then you may be calling the function just to test if a value is true or false inside of that class. So you could say, call a function that says is weapon firing. And that function would then look at the internal variables to say, maybe it has a bool that says is firing. And so all the function is going to do is check and return the value of that bool. But the reason you put that into a function is for reasons of inheritance, and there's private variables in this classes that you can't directly modify or sometimes check, and so you'll use a function to kind of, as they call an accessor, to find out what that value is. But that's definitely optional, so there could be anything in here. And for now, I'm just going to put param key and then params. So this would be similar to the variable type. This would be like an integer, and then this would be the name that you were assigning that integer that was being passed in to. So then in the remainder of the body of the function, and same curly braces, just like with a for loop or a structure, everything that this function is going to do will be contained within those two braces. Now that you have this optional param, you can refer to it, inside of the function by whatever name you define here. So if this was a bool called myBool, then you could just type myBool here, and whatever value was passed in is what you're going to be looking at here, what you're going to be accessing. Just for the sake of a declaration, I'm just going to leave that empty inside there. So just quickly review. You have an optional keyword, which we'll go over here towards the end of the function overview. You have the required function declaration, and then you have a variable type, which is going to be your return type for the function, the name of the function, and then you have optional parameters or arguments, as you'll frequently hear them referred to. And that is the basics of declaring a function. So now let's go over a couple of example functions to show you some of the different things you can do, as well as some different options that come with UnrealScript. There's always a few extra things you can do, such as multiple return values. Okay, so the first example we'll do of a function is going to be something simple, just do a little bit of arithmetic inside of it. So there's some common things you'll see, used for functions. I mean, anything can take place in a function. It can call other functions, it can create variables, it can do, as little or as much, I guess you could say, functionality or scripting as you want inside of a function. But it's a good idea just for kind of organization of code as well as just good overall practice. Much like commenting is a good practice, breaking up common operations into a function so that you don't have duplicate code, across your code base is a good idea. So even if it's just as simple as doing some simple arithmetic, it can be very good, if it's something you're going to need to do more than once, or more specifically in more than one place in your script, then it's a good idea to go ahead and make that a function. So the reason I preface that is that the first function we're going to do here is very simple, and you might ask, why would you put that in a function? And in this particular case, you may not, but it's likely that you would want to do something like this because even though it's not doing a lot of work, it's something that you may need to check in multiple places. And again, you want to reduce the occurrence of duplicate code. So we're going to do a simple function to compute the amount of damage based on the fire stat. And we're referencing our structure with the 4 base stats, such as fire, water, earth, and air. So we have our comment kind of heading, and you can be more verbose in the comment. A lot of people have function headings that involve multiple lines of commenting, such as like a description of what the return value is, both in type and also a verbal example of what type of reason you would call this function or what you should expect when calling this function, as well as if you have multiple params or arguments that you're passing into the function. A lot of times people have a convention where you'll list those out, with each have their own comment about what you should be passing to this function and what's going to happen as far as operations on it. We're not going to go crazy with that, but just know that that's a good practice, especially if it's already in place as a expectation, or where you're working or what you're working on, then just know to follow that. Okay, so for this, we're not going to do an optional keyword as we were talking about up here. So we're just going to start out with function. Oops, you already see I missed the variable type. So we're going to be returning an integer. So we've declared a function, and we're going to return an integer, and then we're naming the function. So now we have our params. So what we're going to pass in is 2 different values here. We're going to do an integer, and what we're going to call that is the base damage. So we're assuming that this there's some base damage for an ability that the player is casting or using, and then you've got your stats that we defined in the structure that work as modifiers, like basically a buff to that. So we're going to just assume it's very simple, that you have a base damage value, that this ability does some base damage, which is stored off somewhere, so you can easily reference that and pass it into the function. And then we're also going to have the fire stat. So inside here, what we're going to do is we're going to take base damage and we're going to multiply that by the fire stat, since we're treating this as a buff. So we can do this a few different ways. We'll start out with the simplest way and most straightforward. So we're going to set base damage. Whenever you pass values in as parameters, the function has a local copy of that, so you can use it and modify it without worrying about modifying the actual value of the variable that you passed into the function. So when you pass something into a function, unless you're using specific keywords, you're getting that by copy and not by actual value. So we can do this and change the value of it without worrying about messing with anything outside of the scope of this function. So we just do something as simple as base damage multiplied by fire stat. Now, another thing that you can do here, if we go up to, go ahead and put our semicolon in, let's forget that. If we go back up to where we defined the structure, you've got this element type rating, and we talked about how you can have as many variables as you want here. What we're doing with this function right now, as it stands, is we're just passing in the integers. So presumably when we called this function, we would have said compute fire damage, and we would have said, passed in some base damage value. Could be the same name, could be something different. And then we were doing my stats or my stats dot fire, which you can see is right here. So we've been, operating on this. So if we had defined a MyStats, or you had a local member variable that was this element type rating in MyStats, and you get fire. So by calling it this way, we're actually passing in the value of the fire stat directly to the function, which matches because here we're looking for just an integer value. Another option is if you wanted to write, say, a more generic function than just compute fire damage, it could just be compute damage based on stat. You could, conceivably write a function that was like compute damage based on stats. And here you would actually be passing in this as a variable type. So if we copy that and paste that down here, and then we'll change this to, my stats, just to keep with the naming. So then here we would basically need to do exactly what we did here when we called the function. We would need to be referencing the member variable or the structure variable of fire inside of my stats, which is what was passed in. So again, just saying there's multiple ways you could do this. If you wanted to make this function more generic and you just wanted to say, pass in my stats and then pass in the base damage and do the multiplication, then you could have additional logic inside of this function, which was checking for, what the current ability was from a type standpoint. If that was the case, you'd probably need to add an extra variable, which was the enumeration. Or actually, we never defined an enumeration for this, but we could easily do, just like we did for the enum of the developer type, we could define another enumeration which matched the fire, air, water, earth. And then in here, you would basically pass in a value to the saying which stat you're wanting to basically use as the modifier. And so, you could basically add a third argument down here, and it would be the, enum stat, or I'm just making this up on the go, but you could be passing that in, and then here you would be checking inside, doing an if check to see like which stat is it. Okay, or it would probably be a switch would be a good flow control statement for that. So based on the 4 different stats, you could switch on it and have 4 different cases that would check the appropriate variable. So kind of getting a little abstract here, not really important, but I just wanted to make sure it was clear that you can pass in your own custom types, variable types, or classes, or structures. It doesn't have to be one of the provided, kind of default variable types in UnrealScript. But for simplicity, we're just going to keep this as we had it. Going back to what we have base damage passed in and fire stat, and just assuming a very simple formula, this would obviously generate a very, very high damage amount based on your fire stat if we were doing just simple multiplication, but this is totally valid. And then what we would want to do is return base damage. So we've said take my base damage and set it equal to base damage times the fire stat. So if this was 10, you'd have a multiplier of 10, which might actually make sense if it wasn't a scale of 0 to 100. If this was a scale of 0 to 10 and you were just treating it purely as a multiplier, then that would actually be fitting. It's kind of all on how how your game was balanced and what range of tuning and types of control the design team wanted to have over how this stuff was generated. But going back to this, we just are basically doing a simple multiplication, catching that value inside of base damage. So we took it and then we altered it. And you can do this because it evaluates what's on the right side of the assignment operator first. So it's going to take this as the value that was passed in and then multiply that by the values passed in and then set base damage equal to that operation. So going forward, as we refer to base damage here, it is now the value of this operation and not what was originally passed in. So that's it. Right there you have a simple function that would take your base damage value, multiply it by your fire stat, and then return that value. As I was saying, this seems like a very simple function, and granted, you may not put this into a function if you only ever needed to do this once or even twice, especially since it's just doing simple arithmetic and, not doing a complex series of checks that would be hard to remember or hard to duplicate somewhere else. But in general, it's kind of good form because you just create very readable code when, you're writing something and, say the player triggers, an attack, and you've got a function that's like generate ability. I think that's one we named up there. And you do something in here, and then After that, you want to compute the fire damage, so you would call our new function and pass in your arguments here, or params as they're referred to in UnrealScript frequently. And then you could say there's another function that is actually apply damage to target. So, and then the other thing that's cool about functions is that not only can you call a function within a function, but you can also technically kind of pass a function as an argument. And that's not really true, but that's what it looks like when you use it. So let's go run with another scenario here that this apply damage to target takes a single integer value. We know that compute fire damage is returning an integer value. So instead of having, that simple integer value, so we caught, let's just go ahead and do this. Amount damage is equal to compute fire damage. So right here we were calling the compute fire damage function. The returned integer value would be stored or saved into this variable here, presuming that this was an integer. And then we could take this value and pass it into this function if this function was looking for an integer. What's kind of cool, and you have to find the right balance on this type of thing of what's the most readable. Sometimes being explicit with it and saying, this line is doing, this operation, and then this line is doing a separate operation is fine and maybe more readable. But just to be clear on what you can do, there's no reason that you couldn't do this as long as you are passing in the appropriate parameters, because this function returns an integer, and the way the script compiler is going to handle this is that it will call this function and complete this function, which is going to return an integer before this function is executed. And so it's going to take that return value as the value passed in. So it's doing the exact same thing that you were doing here by storing the value and then explicitly passing it in as a variable. Instead, you're basically just sort of making the return value transparent and passing the return value directly to the applied damage to target. And if you don't have anything else that you're going to do inside of the function with this output number, then that might make sense. If in addition to apply damage to target, you needed to do any additional function calls that needed to know the amount of damage that was applied or passed to the preceding functions, then this would not make sense, because you really would want to cache it off into this variable so that you could reference it multiple times. Two ways of doing it, and sometimes that way is more clean, but in a lot of cases it's more readable to just be explicit with it, even if it is a few extra lines of code, or it looks like more code than you need. It might just be better that way. Like, there's always kind of that debate of consolidating your code as much as possible, but you can make things so abstract that it makes it very hard to read. And so either if you come back to your code later, or somebody else comes to look at your code and needs to try to fix a bug or add some new functionality, it's become so cryptic that it made sense to you at the time, and technically it functions, but it's really hard for somebody to kind of decipher what was going on and work through it. So sometimes being kind of line by line explicit is the better way to go. Backing up here, just talking high level about how you could use this stuff, going back to what we have here, and that's your basic kind of function in a nutshell. Really quickly, before we move on to some of the things I wanted to show you, I'll go ahead and put this here for reference with the comment of or. So what you could do here is just the way that the operators have been overloaded in UnrealScript, and you'll see this in C++ too. This whole line can be altered by saying, instead of multiplying that there, you can just say times equals or multiplies equals. And there's an operator kind of overload that they've written into the script that will handle this and know to take this value, multiply it by this, and then save the value here. It does the exact same thing as this line right here, but you just save a little bit of typing, and it's pretty clean. And this is one case where it's not less readable in any way. It's once you're familiar with how the operators can be overloaded, and it can be plus equals or minus equals or multiply equals. And then there's yet another option, which is even cleaner or simpler, which is that you don't even really technically need to catch the value, since you're not doing anything else with it. Kind of going back to what I was just talking about with the function kind of passed as a parameter, or passing the return value of the function as a parameter directly instead of saving it off. you can kind of do the same thing here, because in this case you're not doing anything else with base damage in the context of this function besides passing it. So you can really just go with what we did up here, change this to times equals, and then you don't really need this because all you're doing is kind of passing that. So what we're going to do here is cut that and paste it in there, and we're just going to simply return the value of this operation. In that case, you don't even need the equal sign, because you don't. The only reason we needed to save that value was because we were going to be passing it or returning it on a separate line of execution in the script. But in this case, when we're just modifying local variables, we don't need to save the value. All we care about is returning the result of this multiplication operation. Then the cleanest way is this, and this is what you'll most commonly see. This is a good way to kind of learn and understand the flow and how the return statement works and how local variables work. But at its core, this is the cleanest and simplest way to do it, and all three of these would behave the same way or have the same outcome. Okay, so in addition to just the basic function kind of declaration that we've gone over, there's a couple of optional param keywords that you can use. I wanted to cover one of those really quick, and it deals with how you would have multiple return values if you needed it. By default, a function will always just return with the return keyword whatever value type is defined right here as the variable type for the function. So you're going to be returning a single integer. There is a way to return multiple values, and that's using a param keyword. So we have here a function called increment stats. One way to do this would be to actually pass in or tell the param declaration that it's looking for, that structure that we defined up higher in the file. That's going to just pass, by copy, by value, that structure. And then you can increment each individual component of that inside the function. But if for some reason, say you didn't have that structure, say we'd never defined the structure and we were just kind of managing 4 independent variables, which is very possible. In that case, you could have one function increment all of them, but since it doesn't pass by value, it's passing a copy, we need to actually return the value of the changed. If you're used to programming in C or C++, you have the option to pass the reference to the variable, and you're actually changing or altering the variable that you passed in as it exists in memory, and not a duplicate value that gets copied when the function is called. But in UnrealScript, you're always operating on that copy. So what they did was they added this keyword called out. And so you have this. So right here, what we have is a way that we could increment our stats, and we'd be passing all 4 individual stat values as they exist in that structure. And then we could do, just whatever arithmetic. In this case, we're doing a simple incrementation, so we can just do a plus equals 1 is the way to increment something. And we can do the same thing. One thing I like to do in programming is keep similar rows where you're doing a lot of the same operations. You can just tab them over and line them up on a tab order. The white space is allowed. So right here what we have is, that's it, the function's done. It's going to actually take these values and return them back to the function when it's done. So you have basically four different return values by adding this output or out keyword to the param. So that's how you would return multiple values as opposed to the default one. That's it for functions. What we're going to do next is go over classes and how those can have their own internal functions. How you can create your own variables that are member variables of that class, as well as inheritance.